Alright class, in this video I'll be doing the first two examples from section 8.2, the composition of two different trigonometric functions. The first problem states, find the exact value of the inverse sine of the cosine of 11 pi fourths. And before we start, what you'll notice is that 11 pi fourths is not on the unit circle. It's actually larger than 2 pi. So what I'm going to do is I'm going to find a coterminal angle to work with. So 11 pi fourths minus 8 pi fourths is 3 pi fourths. So I'm going to rewrite the problem as the inverse sine of the cosine of 3 pi fourths. From the unit circle, you'll find that the cosine value of 3 pi fourths is the negative square root of 2 divided by 2. So we have the inverse sine of negative square root of 2 divided by 2. Now, since the negative square root of 2 divided by 2 is negative, what we're going to do is we're going to look at quadrant 4 for the solution. And when looking for an angle in quadrant 4, you must use negative angles. So the angle whose sine value is the negative square root of 2 divided by 2 is negative pi fourths. So the inverse sine of the cosine of 11 pi fourths is equal to negative pi fourths. Example number 2. Find the exact value of inverse cosine of the sine of negative pi fourths. First thing you're going to want to do is you want to figure out what is the sine value of negative pi fourths. And that is negative square root of 2 divided by 2. So what we have so far is the inverse cosine of negative square root of 2 divided by 2. Negative square root of 2 divided by 2 is a negative value. So I'm going to come over here to the chart and notice if you input a negative value into a inverse cosine, your angle is going to come from quadrant 2. So the angle whose cosine value is negative square root of 2 divided by 2 in quadrant 2 is 3 pi fourths. So the inverse cosine of the sine of negative pi fourths is equal to 3 pi fourths.